You can see a lot of colorful CFD simulation results here. In this video we will learn what goes behind these CFD simulations. The million-dollar question: what exactly CFD is searching for? Assume this is the volume where fluid flow occurs. Or, this is my control volume. In a CFD problem, what I have to solve is velocity field and pressure field inside the control volume. More precisely, we want to find out U, V, W, and P throughout the domain. So, it will be a function of x, y, and z, plus time, if the problem is unsteady in nature. If we can solve these four unknowns, we are done with CFD. You know, to solve four unknowns you have to have four equations. So next step, let's derive these four equations. To formulate these equations, we will use conservation principles on a small control volume. First principle is conservation of mass. This will lead to an equation where you will say rate of increase of mass at a given point is mass flux in minus mass flux out. It can be represented in differential form like this. Remaining three equations are derived from conservation of momentum, which is same as Newton's second law of motion. Since momentum is a vector quantity, there will be three components for it. It will generate three independent equations. It can be represented in differential form like this. For each direction, there will be one equation. So, in total you have got four equations. All these equations together known as the famous Navier-Stokes equations. And if you can solve these four equations, you can find out the four unknowns. But, analytical solution like this does not exist for NS equations, because these are highly nonlinear coupled, partial differential equations. The only way left is numerical method, where instead of solving for general case, we will solve the problem for particular case, at discrete points. There are various mathematical techniques available for numerical solutions. If you solve NS equations numerically, that method is known as DNS. A highly accurate method. Results of DNS are even more accurate than experimental results. But, if you try to solve a practical flow problem using DNS, even the most powerful computer will take years. So, DNS is used only as a research method. We can apply this method when flow is very basic. We will see how to solve NS equations for practical flow problems in next video lecture.